Wait, wrong keyboard. Okay, same diagram. Okay, we're going to look at velocity. So the velocity is dRB over dt, and this is equal to dRA over dt, and plus by dr point B relative to point A over dt, right? So over here, we know that this is VB, and this is equal to VA. Now, question for you, okay? Can you tell me what's the definition of rigid body relative to point A and point B? The distance will not what? The distance is always what? Fixed. Now, asking you a question now, which seems really obvious, then what is the velocity of point B relative to point A? Yes, it's equal to 0. Why is it equal to 0? Rigid body, okay? So it's equal to 0. Why? Because it is what? Rigid body. Okay, rigid body means this point B and point A distance did not change. Okay, so this is equal to 0. So therefore, from here, we realize that in translation, velocity at point B is equal to velocity at point A. And this is only true for translation. Okay. Likewise, in terms of acceleration at small a at point B is equal to acceleration at point A. Okay. Right. So the next thing that we're going to, so that is purely for translation. Next, we are going to look at rotation about a fixed axis. Okay, so if I can get the diagram. Wait, let me see, is this the right diagram to put? Yep, this is the right. So if you can get this diagram across your notes. Okay, so we are going to press sequence. So the thing that we're going to highlight now is in angular motion. Okay, angular motion are only possible with bodies undergoing or undergo angular motion. Okay. So angular displacement is a measure of the theta, right? Where theta is in radians. Okay, so this is d theta over here. So as we know, angular velocity, okay, omega, and omega is equal to d theta over dt. And v, right, is equal to omega cross r. This is not times, this is vector, this is what? This is cross. Are we clear? Okay, so we have to be careful because later on we're going to solve some complex problem using this analysis. Now there's another diagram that I think I've just posted today. Okay, and can you all go on to Avenue? Okay, this diagram is available. So next I'm going to highlight, so we know velocity. Next we are going to talk about briefly, okay, this is just a brief chat about angular acceleration. And then we'll come into a work problem. I know you're bored. I'm also bored, okay? So if you look at angular acceleration, alpha is equal to d omega over dt, where alpha is defined as the angular acceleration. So we know that omega is equal to d theta over dt. Okay. So we can write alpha will correspond to d over dt, d theta over dt. Right. So this is equal to d squared theta over dt squared. And then with this relationship, note that we are aware that omega is equal to d theta over dt. And we also know that alpha is equal to d omega. Hey, my equal sign gone missing. This is equal to this, right? So from here, we know that dt can be equal to d theta over omega, and this will be equal to d omega over alpha. Okay. So finally, we can have a relationship where the angular acceleration multiplied by d theta is equal to omega d omega. Okay. So this is another relationship that we can get. Okay, so the last equation is how to relate. This equation is interesting, right? It relates acceleration. It relates what? Angular displacement with what? Angular velocity. Okay. So this is a very important equation over here. Very versatile. Right, so we are going to look into this first problem. And the first problem is on yesterday's notes. I've attached the problem. Okay, if you can go to yesterday's notes, you will see this example over here. Okay, example number 1. For a short time, year A of the automotive starter rotates with an angular acceleration of alpha A is equal to 450 t squared plus by 60 radians per second squared, where t is in seconds. Determine the angular velocity. angular displacement of gear B when t is equal to 2 seconds. Starting from rest, the radii of gear A and B are 10 and 25 millimeters respectively. Okay. Diagram below is the motor. Okay. As we know, here we see gear A and we see gear B. Now, if we were to go back to our textbook, I hope, if I can find it. And if we were to that's why I don't like to do particles. So by right, I have to start from this chapter, theoretically, but I break every rules. And as I told you, the next time I've been stopped by police for speeding, I need to go to the driving school again. All these three formulas can we use in what we have? That's what we're going to apply. Yes or no? Right? So these are known as very famous formulas, right? Equation 12.4, 12.5, and 12.6. Have you all seen it before? Right? So what is so different from what we have now compared to looking at particles is what? Acceleration is not a what? Constant. Are we clear? Right? So if we go back to our problem, what we see over here is given to us that the acceleration is what? The angular acceleration is a function of time. So note the angular acceleration, which is alpha angular acceleration of point A, is equal to 450 t squared plus by 60. And this is in radians per second squared. So what this means is what? When time goes bigger, what will happen to the acceleration, anyone? It will go higher, yes or no? If you were to sketch a graph, how will you sketch a graph? Right, so if you were to sketch a graph, just come here, okay, just to clarify some things with yourself. You have alpha, if you have time t. When time is 0, what is the acceleration equal to? 0. When it's t squared, when it's not 0, what will happen? It has a y-intercept, isn't it? It will cross 60, okay? And then it will, so once it has value, I'm just going to sketch a general trend. It's going to look like this. Okay. No, you're not, you're intercept at 60, am I right? Okay, so I think we'll do this. Okay, so this is what? 60. Okay, so this is how a sketch will look like. Okay, so for the angular velocity. Now, so the first thing we have to do is we have to determine right? We have to determine what is omega b, and we have to determine what is theta b at t is equal to 2 seconds. Okay, we want, and what we have known is RA is equal to 0.01 meters, and the radius of B is equal to 0.025 meters. Okay, so we have no other information. Okay, So if we were to sketch, anything, you have to have a relative transformation. So this is x, y,